Hi there, algebra students. It's Mrs. Tremblay. We're starting Unit 7, all about polynomials. And maybe you've never heard that word before. You've probably heard of polygons. It's not the same as that. Basically, you're going to see it's something that you have learned about before. You just didn't know that it was called a polynomial. There's different kinds of nomials that we're going to talk about today. So first off, a monomial. What on earth is that? It's a number, variable, or product of a number and one or more variables with whole number exponents. In the past, you called them terms. Remember all that time we spent combining like terms, reviewing that at the beginning of the school year. So terms are basically called monomials. And there's all this criteria for what makes a monomial. So I have some examples of what monomials are. Notice it's a single term. And we said that it's a number, okay, a variable, or a product of a number and one or more variables. So here I know I have 1/2 and y squared, but they're not separated by an addition sign or anything. That's a product. They're being multiplied. And it says that we can only have whole number exponents. This 2.5 right here, that's a coefficient. It's not an exponent, so that's totally allowed. So these are all examples of monomials. Over here, I have examples of not monomials or counter examples. So right here, I have x to the 1.5 power. That's not a monomial. Why? Well, you can't have a non-whole number exponent. So we can say here that cannot have decimal exponent. You should write that. Everything I write, you should write. Makes it easy. All right, the next one, you might be thinking, well, this is fine. There's no addition or subtraction going on here. They're not separated. What's the deal? What's the problem? You're not allowed to be dividing by a variable here. There's only products allowed. A number and a letter are allowed to be multiplied, but you cannot divide by a variable. So the variable cannot be in the denominator. And last but not least, in this little set, I have 7 to the y power. And you might be thinking, well, that's fine. Y doesn't look like it's a decimal. Well, couldn't it be? Couldn't y be anything? Yeah, so if you see it like this, this isn't considered a monomial because you can't have a variable exponent. Cannot have a variable exponent. Look at all that writing we've had to do. Oh my goodness, I'm exhausted already. We just started. Just kidding. All right. So now we're going to talk about something called the degree of a monomial. Yes, all kinds of fun, fancy terminology here. So the degree of a monomial, I'll ask you. You'll look at a monomial and I'll say, what's the degree of this monomial? And the degree of the monomial, it's the sum of the exponents of the variables in the monomial. Find the degree of each monomial. So all we're going to do is we're going to add up the exponents in each term, and that gives us the degree. So here, I see an exponent of 2. And it's only the exponents of the variables. I realize that 5 really is to the first power, but it says the exponents of variables only. So this is a degree of 2. This one here, the 1/2, don't worry about that, but I see I have an x and I have y to the third power. You might be thinking that the degree of this is 3. It's actually not. This x, just plain old x, really means x to the first power. So to find the degree of this, you have to take 1 plus 3. So this is actually the 4th degree, rather than the 3rd degree. Did your parents ever give you the 3rd degree? Yep, I do too to my kids. It's a parent thing. Okay, so do we have any variables going on here? No, I don't. So the degree of this is 0. We don't have a variable being raised to a power here. We just have the -7. So that's how you find the degree. Pretty simple, right? Look at the term. There's no addition or subtraction signs in any of these. Just look at the term and add up the exponents of the variables. All right, next. Finally, we're going to talk about what a polynomial is. That's the title of our notes today. A polynomial is a monomial. So they're kind of one and the same, or a sum of monomials. So it's kind of like that whole, is a rectangle a square or is a square a rectangle kind of thing. A polynomial is a monomial, okay? Or the sum of monomials. So it's several terms together. That could be a polynomial, or just one term. Each monomial is called a term of the polynomial. And terms are separated by addition and subtraction signs. I know lots and lots of vocab. We'll talk more about it in class 2, don't you worry. But basically, polynomials are kind of like those expressions you've seen earlier in the year where I said, hey, combine like terms. A polynomial with two terms is called a binomial, and that makes sense, right? That prefix does mean two. And an example of that, 5x plus 2. I have two terms being separated by an addition sign. That's a polynomial. A polynomial with three terms is called a trinomial, which makes sense because that prefix tri. So again, we see that we have three terms that are separated by an addition sign. All right. Next on our list here, and to move all my pens, pardon me, is how to write these in standard form. The degree of a polynomial is the greatest degree of its terms. We know that. A polynomial in one variable is standard form when. So this is how we write it in standard form. When the exponents of the terms decrease from left to right. A polynomial in one variable just means that I'm not using several variables here. It's just one variable that we use the entire time. So take a look. Here are some polynomials. This is a monomial. Here's a trinomial, a binomial, and a trinomial. So we've named them. Oh, that was at the end here. Let's do that. So here I have a monomial. Why don't you just write that? I'm okay with that. Here we have three terms. That makes it a trinomial. Here we have two terms. That makes it a binomial. Here we have two terms, also a binomial. And here we have three terms. That makes it a trinomial. So again, all you have to do to figure out what type of polynomial it is count the number of terms. Count the number of monomials, and they're separated by these addition and subtraction signs. So this would not count as two separate monomials. This is one because it's 5 being multiplied by the x squared, not added to. Okay, the next one, let's just do the degree. Kind of a recap of what we've been doing. I'm saving the lengthy one for last. I like to do that, the best for last. When you look at this, remember degree, we just look at the variable and we're adding up exponents. So I have z to the 4th power, there are no other variables, it's a 4th degree. Here it says 5x squared minus x. Okay, now you might be thinking, oh, well this x has a 1, aren't I supposed to add those together? It says, the definition was that the degree of a monomial is the sum of the exponents of the variable in the monomial. We're not putting them all together, you just look at the highest one. So when you're listing the degree is the greatest degree of its terms. That's what this underlined statement says. So right here, there's an x, but this one is x squared. That's greater than that. So this degree would be 2. Here, I see q here, and I see q to the 5th power here. The degree of this one would be 5, because q to the 5th power is greater than just q. Here, I see z. This doesn't have a z over there. And you might be thinking, oh, it's 0. No, when you don't see an exponent, it's really like there's a little 1 there. So this is the 1st degree. And here there's a whole bunch of t's, but the highest one is t to the 3rd power. That makes the degree of this 3. All right, now it's time for standard form. And I told you that to write things in standard form, the terms decrease from left to right. That means the highest one goes on the left and the lowest one goes on the right when you're looking at the exponents, the degrees of it. So standard form of this one is a piece of cake. There's no separate terms here. There are no separate terms, so I just rewrite that. Here, there are 3 separate terms, and these are actually not in order. This is not standard form. That's not how you're supposed to write it. It may help you to keep change. Some of us, as we look at this and you see minus x, we're still thinking that means that that's a positive x. It's not. Subtracting an x is the same as adding a negative x. So that really means it's a negative x. So what I'm going to do is I'm going to look for the highest exponent. That would be this term here. That one gets to go first. And I'm allowed to mix these up because the order that I add 3 numbers doesn't matter. The order that I add any number of numbers doesn't matter. All right, next. All right, this one has an exponent of 1 on it. letters go before the numbers. This one does not have a degree to it. Remember, if it doesn't have a variable, it has no degree. So this has 1, and I'd write that. That's standard form. In this one, it's almost there. You just got to flip-flop them. This q to the 5th power is a higher degree, so that gets to go first. In letter D, there's some subtraction, so I'm going to keep change it. Now maybe you're thinking, oh, well, it doesn't matter, neither of them have any exponents written there. Remember, the 4 doesn't have a letter. That means this is a degree of 0. The variable has a degree of 1. So I'm going to write this as negative 9z plus 4. And this is where, if you didn't keep change it, you may have thought that was positive, even though it's not. All right, I'm going to keep change again over here. And with this last one, the highest degree, the term with the highest degree, would be negative t cubed. The next one would be t squared. And the next would be negative 10t. So basically, we've learned how to identify the degree of a monomial or polynomial. You just look for the highest exponent in whatever monomial you have. The monomial with the highest exponent tells you the degree. The type of polynomial depends on how many terms there are. If there's 1 term, it's monomial. 2 terms, binomial. 3 terms, trinomial. And then in standard form, we're putting those in order of the highest degree to the lowest degree with your terms. So we're going to do one more little problem. It's an application problem, so turn your page. And this is the kind of problem you would see in answering all this. Yes, of course, I'll ask you, what's the degree of this? What kind of polynomial is that and that? But here we're actually having to do an application. So the polynomial, and I give you a polynomial up here, negative 16t squared plus v sub 0t plus s sub 0, represents the height and feet of an object where v sub 0 is the initial vertical velocity in feet per second, s sub 0 is the initial height of the object in feet, and t is the time in seconds. Whew! Doesn't this seem like fun? I know. It's not too bad, actually. You'll see. It says, write the polynomial that represents the height of the baseball if, and I'm telling you what v sub 0 is, and I'm telling you what s sub 0 is. So usually when I tell you what certain amounts are, what do? You just plug it in, right? So go back up to this equation up here. I didn't tell you what t was, so we're just going to rewrite this as negative 16t squared plus. I did tell you what v sub 0 was. I said that that's 30 feet per second. So we're going to plug 30 in for v sub 0. I didn't tell you t, so rewrite it. And I do tell you that s sub 0 is 4. So I'm going to replace s sub 0 with 4. That's all that first portion is asking you. It's just asking you to rewrite it with those values that are given. Letter B, what is the height after 1 second? Well, up here it says that t is the time in seconds, right? So what I'm telling you here is that t is equal to 1. So all you need to do again is substitute. Substitute, not just regular 2, because that'd be gross. Substitute. Ha ha ha. You know I couldn't get away with not having at least one ridiculous joke. I can't help myself. So all we did was we plugged in 1 second for time, and now we're going to evaluate this expression. That's all we have left to do. So you could type this in your calculator if you wanted, or you can say 1 squared is 1, and 1 times negative 16 is negative 16, and 30 times 1 is 30. And then, okay, negative 16 plus 30, that is 14. And 14 plus 4, yep, it's 18. And now 18 what, right? What were we solving for? We're solving for feet. So I'm going to write 18 feet. You're done with the first lesson of Chapter 7. Congrats.